Concept is photoelectric effect. Photoelectric effect means when a light of certain frequency strikes the surface of metal, electrons are ejected from the metal. This phenomenon is known as photoelectric effect. So here the light of a certain frequency which strikes the metal surface. This is metal, and light with a certain frequency strikes the metal surface, and here the ejection of electrons. So here this is the ejection of electrons, and this entire phenomenon is known as photoelectric effect. So here the in photoelectric effect, when a matter emits the electrons, so these are ejected electrons. When these ejected electrons absorb the electromagnetic radiation means nothing but light, sunlight. So when they absorb the electromagnetic radiation, they undergo ejection. They undergo ejection. But in photoelectric effect, we can't use all the metals because only few metals shows this effect under the action of visible light. But many more show it under the action of more energetic light like UV light compared to visible light. For example, cesium, atomic number 55, which amongst the all the alkali metals has the lowest ionization energy. Lowest ionization energy means the energy required to eject the electron from the outermost electronic orbital. So cesium has the lowest ionization energy. It means the cesium undergo easy ejection of electron. So these types of metals are used in photoelectric cells. So these types of electrons are used in photoelectric cells. So this is the representation of photoelectric effect. This is a metal surface. When light strikes the metal surface, there is the ejection of electron. So these ejection of electrons are detected by the detector. Correct. So here one more thing is, for a certain minimum frequency, we told that the incident light with a frequency. So the minimum frequency required to eject the electron. Correct. The minimum frequency of incident light required to eject the electrons from the metal surface. So that frequency is known as threshold frequency. And one more point is the kinetic energy of the ejected electrons are independent of the intensity of incident light. And next one is the number of ejected electrons. Here 1, 2, 3. So these are ejected electrons. The number of ejected electrons from a metal surface depends on the intensity of incident light radiation. So here the difference is the kinetic energy of the ejected electrons are independent to the incident light radiation, and the number of ejected electrons are dependent on the incident light radiation. So this is the difference. And next, the photoelectric effect. This entire phenomenon take only less than 10 to the power minus 9 second. So there is no any significant delay in the phenomenon. So the incident light strikes the metal surface and ejection of electron. Whole entire process takes less than 10 to the power minus 9 second. So this is about photoelectric effect. So this is a practical proof. And next thing is Einstein's equation for the photoelectric effect. So theoretically, we cannot explain the photoelectric effect on the basis of classical wave theory. So quantum theory is the best method or the best theory to explain this photoelectric effect, and this one is very easy method. So here what happened? We already know that light consists of bundle of energy. Light here nothing but electromagnetic radiations. It consists of bundle of energy. That is we called quanta, or we can also call it as photons. Photons. And the energy of each photon being equal to the frequency of light. So here the energy of the each photon is equal to the frequency of the light. So when a photon of a light with a frequency electron strikes the electron, and that electron break away from the metal surface. So this photon, this bundle of energy is absorbed by the electron, and those electrons break away from the metal surface, and those are ejected from the metal surface. So we can represent mathematically here energy supplied. This is the energy supplied incident light or photon with a frequency is equal to the energy consumed in ejecting an electron. So here the energy consumed means the energy whatever is supplied that is absorbed by the electron. So that is energy consumed in ejecting an electron plus maximum kinetic energy of electron. After the ejection, the electron starts to move away from the surface, and that kinetic energy here energy supplied is equal to energy consumed plus maximum kinetic energy of electron. So we can represent E is equal to work function plus kinetic energy. So here the E means h nu. E means h nu, and work function xi is equal to h nu naught. Here nu naught is threshold energy, minimum energy required to the ejection of electron. And here kinetic energy is equal to half mv square. Half mv square. So here substitute these three values here. H nu is equal to h nu naught plus half mv square. H is equal to this is nu naught, and this one is v velocity. H into nu minus nu naught is equal to half mv square. This is Einstein photoelectric equation. This is a very important. This is Einstein photoelectric equation.